This is section 5.5, and we split it up. We're going to do the other half of it on Monday. Those are called power reducing formulas. So you're getting a lot of formulas here in the last half of this chapter. These formulas are included in the formulas that will be provided for you on Thursday's test. So the box that you saw at the bottom of your quiz will get bigger, and there will be more formulas inside. So it'll be your job to kind of decide when you should use which formula. Now, the reason they're called double angle formulas is because you're going to double the angle, so it's 2 times the angle. And because we're doing 2 times the angle, that means we can actually derive these formulas for the double angle from our sum formulas. Because when you double something, it's like you take something and add it to itself, right? So I'm going to show you how I derive the formulas. You won't need to actually derive the formulas. You'll need to be able to identify and use the formulas. Okay, so I'm going to start with the sign of a double angle. But before I get into that, yesterday, like if you have your pink foldable, we did like the sign of u plus v. Well, if I want it to be a double angle, let's just call our angle u, the first angle. Instead of adding v to it, if I want to double it, I'm just going to add another u. So it's going to be the sign of u plus u in that formula. So we're doubling u. And then I plug in, if I look at the other side of the formula, that's where we do sine u times cosine v, but in this case, v is u. We keep the sign, and then we had something like cosine u times sine v, but of course, v again is u. So that's just me plugging into that formula with 2 u's, because I want to double the angle. On the left, when I have u plus u, that's the sign of 2u. So there's my 2 times the angle. This is why it's called a double angle formula, because you're doubling the angle inside. What do you notice about the stuff on the other side? The 2 things you're adding? They're really the same thing. I mean, I do have them out of order, but multiplication is commutative, so we could write that second one as sine u, cosine u. So it's like I have 1 sine u cosine u plus another sine u cosine u. So now I have 2 sine u cosine u. So there's your double angle formula for sine. I'm going to repeat that process for cosine. So I'm going to do the cosine of u plus u. Looking at my pink foldable, I'm just following the formula. I'm going to let u be u and v be u. So that's going to be cosine u times cosine u. Remember, with the cosine formula, you do the opposite sign, so it's going to be minus, and then a sine u times a sine u. How can we simplify cosine u times cosine u? We could write that as cosine squared u. So this is saying the cosine of 2u, that's what u plus u is, 2u, is really equal to cosine squared u minus sine squared u. Now you might recognize that that looks very similar to a Pythagorean identity, but be very careful, that is not the Pythagorean identity. If it were, they would have to be the same signs. Both sine and cosine would be positive right there. So this is different. Now, with the cosine, I'm going to amend this formula because you might be thinking about a Pythagorean identity. And what I'm going to do is I'm going to make a substitution. So there's 2 other versions of this cosine 2u formula or double angle formula. So one of the versions, I would do the cosine of 2u is equal to, and where I see cosine squared, I can use my Pythagorean identity. That's really 1 minus sine squared. And then I would be subtracting another sine squared. So now I have like terms right there. Another way to write the double angle formula for cosine of 2u is to say the cosine of 2u is equal to 1 minus 2 sine squared u. Now that substitution would be really helpful if you want to get rid of a cosine and you want to be working in sines, because now you don't have both. You have just sine. And I can also do a different substitution. Instead of plugging in for cosine squared, let me plug in for sine squared, right? So I could say the cosine of 2u is equal to, I'm going back up to this top one, keep my cosine squared 2u, and subtract sine squared u, but use the Pythagorean identity, 1 minus cosine squared u. So I'm just kind of like manipulating the equation that's already there by making a substitution. Be careful on this one. You have to distribute that negative so the cosine squareds don't disappear. It actually makes positive 2 cosine squared. So another version of this is cosine 2u equals 2 cosine squared u minus 1. Now, in the box that's going to show up on your quiz or your test next week, that will have all 3 versions of that cosine 2u formula. So you won't have to manipulate it on your own. Just know that that's why there are 3 versions. We're just substituting in a Pythagorean identity. Now the last one, you should probably feel pretty confident you'd be able to make one for tangent at this point. Tangent of u plus u. We're just following our formulas from yesterday, our sum formula for tangent of u plus u. That would mean in the numerator I would do a tangent u plus tangent u, and in the denominator I would do 1 minus, because I use the opposite sign, tangent u times tangent u. So that's equal to 2 tangent u over 1 minus tangent squared u. Okay. So there's really 3 double angles. We have one for sine, cosine, tangent, but we rewrote cosine a couple of different ways. So we have 5 new formulas, I suppose. So there's going to be, I think, really 2 types of problems that you're going to be working on your homework. One of those is going to be similar to my first example here, and that's a solving. So we're going to solve in the interval from 0 to 2 pi. This is a different set of directions than was on that quiz you just took. On the quiz, if you'll remember, it said solve and give complete solutions, so you should have been adding the period times n to your answers. Some of us are like, yep, did it. Others forgot, right? And that's okay. So you got to pay attention to the directions. How do you know you read the directions? Only answer certain angles if it says 0 to 2 pi. Okay, now, someone in a beginner, we're just looking at this equation, cosine 2x plus cosine x equals 0. Probably the most common mistake that someone's going to do is think about factoring. And I get it, because you're like, oh, let me factor out a cosine or something like that. The issue here is these are not the same cosines. This one is just a cosine of x. And this one is a cosine of 2 times that angle. This is like a cosine 30 and a cosine 60. And those aren't the same terms. We know they have different values on the unit circle. So when they're all cosine x's, yeah, it's the cosine of the same angle. You can take it out. But we can't factor it as is. So what you're going to be looking for now in some of the equations that you do on your homework is there will be a double angle in there. And so it's your job to make the substitution for the double angle. So you see a cosine of 2u. You've got 3 options, right, that we listed on the previous slide. looking at this equation, what's going to be in the equation, I'm going to flip back to my previous slide real fast. Which one of these cosine to use do you think is going to be most helpful? Cosine squared minus sine squared? 1 minus 2 sine squared? Or 2 cosine squared minus 1? The last one. Because then, if I make that substitution, everything will be in terms of cosines. And ours looks like what on the next slide? Cosine 2x. So that means that u is equal to x. So we're just going to do 2 cosine squared x minus 1. Okay, so let's make that substitution. Have a good weekend. 2 cosine squared x minus 1. I'm substituting it in right there. I don't really need a set of parentheses because it's not being multiplied by anything, so I don't have to worry about distribution there. And then plus cosine x equals 0. I can solve an equation that has a cosine squared and a cosine in it. What am I going to have to do? Factor. So I'm going to rearrange this so it looks like a trinomial. I'm going to put my middle term cosine x in there. And I know that my first terms in the sets of parentheses have to be 2 cosine x and cosine x. My last term has to be 1 and 1. And then I will need opposite signs, but a positive cosine x. So that means the 2 cosine x, when I multiply, has to be positive, and the 1 cosine x needs to be negative. So if I set my factors equal to 0, I'm going to do a little bit of work here. I would add 1 and divide by 2, so I'm going to have cosine x equals 1/2. And on the other factor, that would just be cosine x equals -1. If you need to write out the full steps, like set it equal to 0 and add and divide, you can. Just in interest of time, we'll kind of fly through there. And now I just answer the angles, right? So this would be like what you did on your homework or on the quiz, except for we only want the angles between 0 and 2 pi, so 1 revolution of the circle. Can you give me the angles for cosines of 1/2? Pi over 3 in the first quadrant, and 5 pi over 3 in the fourth quadrant, because we got to go to the right for cosine. And then what angle has a cosine of -1? Pi. We're going left 1. So there are 3 angles between 0 and 2 pi that have those cosine values. I think that's the first set of problems. You're going to be looking like at the very beginning, there's going to be a double angle somewhere in there, and you're going to make a substitution. And then, most likely, you're going to have to factor. Okay? Okay, the last set of examples that I want to show you, these can be a little bit weird. First of all, I don't know why my thing does that. So it's all about, I will call it manipulation to make this work. So there's 2 examples that I have up here. And the best advice I can give you for your homework this weekend is look at the problem. It's going to ask you to rewrite it. Look at the problem and match it to one of the double angle formulas that it looks the most like. It won't look exactly like it. You're going to manipulate it a little bit, but it's going to look close to one of the double angle formulas. So if we look at that top one, 3 minus 6 sine squared x, that looks most like which one? The cosine to u is equal to 1 minus sine squared u. And so we need it, 2. We need it to actually look like that, so how can we do that?
Multiply by 3.
Yes, if you factor out the 3 from the 2 terms, then they will look like 1 minus 2 sine squared, won't they? So here you want to factor out the 3. Okay, then we're left with 1 minus 2 sine squared x. In this case, x is u, right? That's what's coming behind the sine squared. So I just need to put x in on that other side. That's really just the cosine of 2x. So now this can be rewritten as 3 cosine 2x. They want you to rewrite it with a double angle. Which one does the 10 sine 2x cosine 2x look like? Most like. Sine 2u. Okay. Now this one's a good one to kind of look at. I know that we're going to come close to the bell, so just stay with me for a second. What's u in this? U is 2x. So when you rewrite it, you're going to be doing the sine of 2 times 2x. That's going to be the sine of 4x when you substitute back in. And then we need to have just a 2 in the front. So just like we took out a 3, we're going to be taking out a 5. But you won't be able to do anything about this 2x and the sine and the cosine. That just means this simplifies to be 2 times 2x or 4x. So it's almost like your angle was already doubled because it's 2x. Now you double it again and it's 4x.
Sorry.
This chapter should be pretty much no calculator.
I have closest state March 18th and 19th, and this sheet's due today, and I forgot the sheet at my house. So if you could sign the sheet of paper, that'd be great.
You need a little folder at your
I know,
house.
I lose everything.